Today, we are going to present our group project. Our topic is application of integration in physics, distance, velocity, and acceleration based on time. My name is Iman Luisayap and my metric number is 270638. Let me give an introduction on our chosen topic, application of integration in physics. Integration assigns numbers to functions in a way to describe displacement, area, volume, and many. It is one of the main operations in calculus. Integration is the inverse of differentiation. The principle of integration is formulated by Isaac Newton and Gottfried Wilhelm Leibniz. Integrals are used in many areas of mathematics, such as probability theory and physics. For example, in probability theory, integrals are used to determine the probability of some random variable falling within a certain range, while it can be used for computing the area of a 2D region that has a curved boundary. By the way, for this project, we are going to discuss about application of integration in physics. Physics is the study of changes in our real life. For example, since the speed, acceleration, and the total distance covered by a car not in uniform motion, we need to apply it by derivative and integral. When we want to know how one variable changes with another, derivative is important. When we want to expand the result of a small element to a certain degree provided it follows certain pattern, integration is important. The infinite integral is applied in problems involving distance, velocity, and acceleration. Velocity is the rate of change in position, while the speed is the rate of change in total distance. By using integration, we can calculate the velocity function from the acceleration function and the position function from the velocity function. That's all for my part.
My name is Lim Zhen Chong and my matrix number is 270181. Now I would like to discuss the key concept in our project. The first key concept in our project is the velocity. Velocity can be defined as the rate of displacement. Since velocity emphasizes the direction of the motion, it can be considered as a vector quantity. The formula of velocity is v equal to s, that is displacement, divided by t, that is time taken. Velocity is very important in many fields. For example, when we travel, we can estimate the arrival time of an aeroplane by knowing its velocity and initial time. From that, we can construct a timetable for traveling. The second key concept in our project is acceleration. Acceleration can be defined as the rate of change of velocity. Acceleration changes only under two conditions, that is, the velocity of the motion increases or decreases, and the direction of the motion changes. Since acceleration also emphasizes the direction of the motion, it can be considered as the vector quantity. The formula of acceleration is a equal to v, that is change of velocity, divided by t, that is time taken. Acceleration is important for us to determine whether the velocity changes over time. For example, a 100-meter runner can analyze his acceleration and realize whether it's his velocity and hence improve his performance. Now I would like to invite my another groupmate to continue the presentation.
Okay, my name is Ji Donghua. My matrix number is 271956. Next, we are going to talk about the methods used in this project. Let's talk about the fundamental theorem of calculus. The fundamental theorem of calculus that links the concept of differentiating a function with the concept of integrating a function. Let f of u is a continuous function defined on a closed interval a to b, and its antiderivative is capital F of u. We can get the formula in the red color. Next, we replace the a to b, become x naught to x, where x naught is the starting value and x is the final value, and change the order of equation. We can get the formula in the blue color. The techniques used is related with the topic techniques of engineering. Next, we are going to talk about the relationship between distance, velocity, and acceleration in graph. First, we fix the acceleration in at equal to 10 meter per second square. We can get it is a constant graph. Since the velocity is antiderivative of acceleration, we can get that the change in velocity is the integral of acceleration over time. And the graph represented in velocity is linear graph. Next, the distance is an antiderivative of velocity. So we can get the change in the integral of velocity over time. And the distance have a graph represented in exponential graph. Next, I'm going to pass the discussion to my teammate about the example question.
My name is Liu Guan Yu and my matrix number is 271021. I would like to present my part, which is examples and analyze. So the question is, in case of a free-falling object, the acceleration due to gravity is negative 32. The significance of the negative is that the rate of change of the velocity with respect to time is negative because the velocity is decreasing as the time increases. A. Find the initial velocity and distance function. B. A ball is thrown downward from a height of 512 feet with a velocity of 64 feet per second. How long will it take for the ball to reach the ground? Solution for part A conditional given is at equal to negative 32. For the step 2, we need to integrate at to determine the vt. After we determine the vt, we need to integrate it to obtain the st function. The procedure is shown as the right-hand side, and the last answer for the vt is equal to negative 32t plus v0. However, st equal to negative 16t squared plus v0t plus s0. For the part B, the conditional given is when t equal to 0, st equal to 512, and vt equal to 64. For the step 2, we need to substitute the information into st, which had determined in the part A. Last, and the st equal to negative 16t squared minus 64t plus 512. And the last step is let the st function equal to 0, and we will get the value of t, which is negative 8 and 4. We just ignore the negative value since we need to determine the time. Hence, the ball will reach the ground 4 seconds after it is thrown. That's all for my part.
Now I will talk about the conclusion of our project. In this project, we have discussed about the application of integration in physics. We discovered that integration can be applied to find the value of the velocity and displacement of the motion. The method used is called technique of integration. From the result of the two examples above, we discovered that we can find the velocity of the motion by integrating the acceleration of the motion. We also found out that we can calculate the displacement of the motion by integrating the velocity of the motion. In this project, we have discovered that mathematics can be used in many fields where physics is just one of them. Although mathematics is always unnoticed in our ordinary daily life, but we cannot deny that mathematics has contributed a lot towards the humanity. That's all from me. Thank you.